I needed some space on this one. This is page 100. We are considering functions in the coordinate plane. And this is number 14. It says to consider the following piecewise function. Which point is on the graph of f of x? So to show you how to do this one, I want to set up a table of values. And I'm just going to draw myself a table. Whenever I have a lot of points like this, I will always draw a table of values just to organize my information. Part of that is because I am dyslexic and I have a lot of trouble keeping things organized in my head. So the table of values just helps me to do that a little bit better. So I'm going to put some labels on this thing. We know x and y. That's what we learned way back in graphing. But x and f of x are also going to fit here. This is the domain, and this is the range. And I'm interested in the x values. Okay, the reason for that is because my piecewise functions are based on x values. So when x is in this range, I will use this function. When x is -1, I would use an 8. And then when x is in this range, I would use this function. So it's the x value that is the independent variable. That's the determinant value. So I'm going to put in a -3, a -3, a 3, an 8, and a 12. And you may be thinking, where is she getting those numbers? I'm getting those numbers right here. Okay. And that was an accident. I didn't mean to put a box around C. C is not the answer, by the way. So I just pulled those x values up here because I want to see for myself what I get for my y's given those x values. So when x is -3, so would that be a blue, a yellow, or a red? If x is -3, that is a blue value. X is less than 1. So this one will use the blue function, as will this one. When x is +3, that would be more than -1, so that will be using the red function. And when x is greater than -1, that would use the red for these two. So we won't use the yellow at all, and that's okay. You don't have to use the yellow. Just depends on your values of x. So for my values, I'm going to use two different functions. So the blue one, it says when x is below -1, f of x, and in this case it's -3, is going to use the function -5 times x minus 3. So this would be 15 minus 3, so that value would be +12. Now, if -3 is the x value, the y value will still be +12. All right, if the value of x is more than -1, we're going to use the red function, which is f of x equals -2/3 x plus 4. So I'm going to use that for f of 3. Fractions are just numbers. -2 times +3 is -6 with a 3 on the bottom. Negative 2 plus 4 is positive 2. So when x is positive 3, y is positive 2. When x is 8, fractions are just numbers. Negative 16 thirds plus 4. Negative 16 thirds plus 4 on your calculator is negative 1 1/3. So that would be the y value. And then one more time, when the x value is 12, you would have negative 2/3 times 12 plus 4. So negative 24/3 plus 4, that's negative 8, plus 4 is negative 4. So these are the true y values for this particular function. We need the one of those that matches. Negative 3, 8, no. Negative 3, 12, yes. Positive 3, negative 18, that doesn't match. Let me just be sure you're with me. That doesn't match that value. This doesn't match that value. Positive 8, negative 1, no, that doesn't match. 12, negative 3, it's close, but not quite. The only one that matches is B. Those piecewise functions were always very hard for me. So if they're tough for you, you are not alone. All right, let me bring in the next piece of this page. I want to get number 15 in frame and see what we have to do here. Consider the following function. Which table represents this function? Well, the good news is that all the x values are the same. So I'm going to do a similar process with this one, where I have a table of values, and you're thinking there's already a table of values. Why is she drawing another one or trying to draw another one? It's because we don't know which table of values is the right one. So I'm going to see what I come up with, and then we'll compare it to the table we have. So let's make a table using negative 2, 0, and 2. Those values right there are the same all the way down. So those are the values I want to use. All right, so here comes the label. We learned x and y, and then we learned x and f of x. Just as review, this is the domain, and this is the range. And the function in question is a quadratic. So, I'm going to plug in negative 2 as my x value. 2 times negative 2 squared minus 3 times negative 2 minus 4. So this is 2 times positive 4 minus 3 times negative 2. That's going to be a plus 6 minus 4. So 8 plus 6 minus 4 is 10. When x is 0, So 2 times 0 squared minus 3 times 0 minus 4. So these terms zero out, and you are left with negative 4. And then when x is positive 2, now don't be tempted to say, oh, I already did that. You already did negative 2, but this will be different, or it should be. 2 times 2 to the second power minus 3 times 2 minus 4. So this is 2 times 4 minus 6 minus 4. So this is 8 minus 10. That's negative 2. Okay, we want to see which table matches our table. And I like A. That's the one that matches the values that we found when we did a table. All right. One more, and I bet I can't fit it down here. No way. Okay. Let me crop this, and I will pull this over to the next page. And plop it right down there. Oh no. Let me try something here. We might be able to squeeze this one in. Okay, I still have to crop it again. I'm sorry, I don't know what I did wrong. Your old teacher is very tired right now. It's 11 o'clock at night, and it has been a very, very long day. Let me move some stuff and see if I can't fit this in, because if I have to try to take it to another page, we're going to be in a mess, I have a feeling. So let's move this right here, and I believe I can make it fit now. All right, and I know that's very small, so if you're looking at the book, you can see this on your book. But for those of you who may not have the book, all right, it says to consider the function below. F of x equals 200x plus 50. Now, this is my kind of function. It's linear, so if I see a parabola, I would know that's not it. And you say, well, how do you know it's linear, Miss Amanda? It's because it's x to the first power. So all of these are linear. Even e is linear. So then we need to look for the slope and the y-intercept. And because it's in slope-intercept form, the slope is 200, and the y-intercept is 0, 50. So I'm going to look for a positive slope first. That's the easiest way. A can be eliminated because it is a negative slope. B is a negative slope. C's positive, D's positive, and E is horizontal. E has a slope of 0. So that one can be eliminated because we know that slope would be 0. All right, so let me explain that a little bit. The slope of A is negative. So it's out. We're looking for positive. The slope of B is negative. It's out. The slope of C is positive. The slope of D is positive, and the slope of E is 0. All right. Now, let's go after that y-intercept. We have two possibilities. I'm looking for 0, was it 50? Yes, and 0, 50. So let me zoom in here. This one looks promising. Every line on this thing is 50. So that is 0, 50. This, there's the y-intercept at 0, 0. So on the basis of the y-intercept, I'm going to eliminate D, and that leaves us with C as our answer. And that brings us to the end of the homework for lesson 6.1. I am going to go back to my page here and just put these answers in if I can remember them. This one was B. I do remember that. This one was A. We didn't have to go far. And then this one is C. Just in case you are following along that way. All right, I think I'm going to go to bed for tonight, and I'll see you back in another video for lesson 6.2, which will start on page 101. I do encourage you to try those on your own, and then meet me back for an explanation if you should need it. And I'll see you soon. Bye-bye.